Today on Crazed Performance Repair, we're going to talk about this hone machine that I have made. It's an automatic hone machine. You can see how as I turn this, it actually goes up and down. I did do a YouTube short on this thing, as you can see here. I have built a fancy-dancy cylinder hone, small block Chevy oil pump driven by a window regulator from a Ford, operated by an Amazon motor, link in description, of course, and an air compressor from a GTO that I happen to rip apart to operate the arm. I will turn on the pump here, let you guys check it out, and turn on the motor. There we go, there's the thing operating. See the coolant flowing, nice low and slow. I can speed that up, of course, if I want, but there's no reason to. It's a pretty cool thing. There was a lot of commentary and people basically want me to do a video on it. They asked if I did a build video. I did not. I wasn't planning on making a video on it, but there was enough response. I said, I gotta make a video on it. But this is take 6 or something on the video. So before I actually get started, because of a few interruptions, in turn. And then I have get a bit hot, so I added a little extra cooling. Because if I'm at 50%, boy, shit, now I forgot where I was. System would allow it to have the correct weight. Notifications are now disabled. So now I won't be interrupted. I'm going to go ahead and actually just start fresh, whole new video instead of using my old footage other than that clip you just saw, and get explaining this thing. Now, we're going to kind of cover how I built it. I'm going to talk about the materials used, the expense involved, my expense versus what it would cost somebody else to do it, for example. If you were to actually have to buy the products, what would it cost you to build this unit? If you are looking at actually having a hone machine yourself similar to this, this is a very, very budget-friendly solution to a rather expensive hone. This one, I literally only have a few $100 in this thing, including the hone oil, which is $160. And the rest of it is stuff that I had here. But, of course, that would cost somebody like you, unless you happen to have some of this here, for you to build it yourself. So, let's go over all that, show you what I did, how I built it, what things you might not be able to do and you're going to have to improvise in a different way so that you can do them, because I have a milling machine, I have a lathe, so there's a few things that I can do that you might not be able to. But if you have access to some of that tooling and you're able to do it, that's probably why you're building this. You probably have the tooling to do that, but you don't have one of these. So if you don't have access to that, I'll give you other options, I guess. You're just going to have to be more selective with your parts. So let's start way down on the bottom of this thing and work our way all the way to the top to the actual meat and potatoes of the device. So the whole frame here, this part, is this 2x3 steel tubing. And I have some 1x1 angle iron for some support bracing. And that's some pretty heavy angle iron. Actually, you can see it right here. This is the same angle iron right here. So it's some pretty good size angle iron. This here is a 2-inch shaft for an envelope machine. I acquired it, right? But 2-inch shaft, or you could do 2.5-inch shaft would probably be fine too. I don't think there's much for cranks smaller than 2.5, unless you're going to be doing Briggs and Stratton or something. If you're going to do something like that, you might want to have a couple different shaft options, maybe. Yeah, I don't know how you want to do that. But I built this basically for V8s. I am going to build a plate system that can go on here for swiveling. That way I can put a flat plate on here and bolt things to it. So if I have like a set of jugs I had to do that don't actually have a crankshaft hole to go through, I'll be able to do that. Now, down here at the bottom, we have this come from just a piece of plastic off of one of those plastic 250-gallon totes. This is actually the label cover. I'm using it as a deflector. This is some household flashing you could get at Menards. It just deflector for oil for splashing. This is also some flashing material. It's part of a roofing material, and it's just thin tin, right? Any kind of thin tin you can find to create splash, things to prevent the splashing and make it go back in this tank is all you're going for. I do have a magnet stuck to this to hold this in a certain position. This is actually the bottom shelf of a parts washer. So underneath the parts washer, there's a shelf on a cheap parts washer. this is the parts washer tank itself. I had a parts washer I had no use for because I use an ultrasound now. And this thing just takes so long to clean. I use a pressure washer and an ultrasound. I don't even bother with the parts washer. So I thought, let's repurpose it and make it more useful. So this is the parts washer tank. We have, of course, it sitting on the frame, and the frame sitting on some casters. This caster isn't even touching, clearly. So I must be in a weird spot on the concrete. But we have some casters, so I can roll the thing around the tank. And the tank has some baffling. Now, inside the tank, we have to pump the oil for the hone machine, right? So I had to build a pump in order to do this. I was searching on Amazon for pumps that could pump oil. I couldn't find much other than there is it's like an actuator pump. It basically has a little diaphragm inside that electronically cycles with AC current. And there was one good review on it. Maybe, I think there might have been 2 reviews total, but the one review didn't have any words. The only thing the guy said was, it worked great for my coolant pump on my machine. And I'm like, maybe it would work. I don't know. Can it pump this thick of an oil? And I said, you know what? I'm just going to build my own pump. So I actually have here my own pump that is driven through 12 volts. The only reason I chose 12 volts is because of parts availability and the fact that I have a 12 volt hookup attached to my solar system that's already plumbed into the shop. So it's not a big deal to use it, and it's plumbed in my shipping container. This thing's going to end up in my shipping container later on. I powered a 12 volt motor here, and I'll show you the motor in a second, and it's pumping an actual engine oil pump. So what we have right here that I'm actually powering and operating the pump with, this is a small block Chevy race pump for a high performance engine that I did, and this pump actually had a couple of damage spots on the gear. So I said, I'm not putting that back in the engine. It's junk. But I kept it for myself. I thought I might find a use for it. Not engine related, but I might find a use for it because it's just a gear pump, right? But small block Chevy oil pump, I had to machine the surface of the mounting surface of the pump because it was not at a 90 degree. So the shaft is like this, and the pump actually mounts like that. So it's not a perfect, it wasn't a perfect surface. So I just machined the surface to make it exact 90 with the shaft direction. And then this is actually a lift block for a truck. You know, you'd put it under the leaf springs and then it'd lift up the truck, right? Between the leaf springs and the axle. So that's actually a lift block for a truck, and I just used it because it's a chunk of aluminum. And I machined it to hook the small block Chevy pump up to this window regulator from a Ford door that I got from my neighbor. He has a bunch of cars sitting at his property. And this is a Ford window regulator that has a worm gear and a big gear that the worm gear turns. And so it's got a high torque motor in it, basically a high torque gearbox, but low profile, small, doesn't draw much current. At full 12 volts, it actually pumps far too much oil. So I added some light bulbs in series with it. I'm trying to find the perfect amount of flow, so I haven't quite made this permanent yet. But this seems to be pretty ideal. I have it running through 2 filaments on one bulb and 1 filament on the other bulb, and it seems to be pretty much about right. So now I just need to find a light bulb with the same amount of current usage. Maybe I'll speed it up a little more yet. I have yet to decide because of the motor, which I'll explain above. I think it'll work the way it is. Well, I know it works, but with the motor I'm going to do it, I might keep it like this. I might not. I'll have to play around when I change the motor that's above, which I'll explain, like I said, in a little bit. But this thing overall works awesome, just like it is. So I do have a heat sink on the motor. It's got a Ford part number on it. I did have to machine a slot in the actual gear that opens the window itself, just so that it can match up with the small block Chevy. And then, of course, I have this plate to make it all so it works together. So this guy is pumping away, working great. This heatsink is from a computer. It's from an Asus that I had sitting in my basement. I do computer stuff. All scrap laying around. I was just hodgepodging things together, but it works awesome. So let's move upward on this project and go to the rest of it. Now, as we move up on this thing, you can see the back here. I have the angle iron support for triangulation of this beam to keep it from flexing too much from the hone. There is a lot of stress on that hone. And then I have a piece of soft aluminum line that's acting as a wire protector for my wires that are running through here. These guys are not hooked up to anything right now. Those are actually the 12-volt system. I still got to set that up with some alligator clamps or permanently mount it somewhere when I move this. I'm putting this in my shipping container. So I'll figure that out later. For now, they're just hanging here. While I was doing the first test on this thing, I had it in the shop here doing it. But, yeah, I'll hook these guys up later. Anyway, so we got the loom coming up here. That runs to here. This is actually the control section. And then this guy here controls the motor. So we have the on-off switch. We have the speed of the motor. I typically run at 40%, and I'll explain a little bit more about that in a minute. We have the oil pump, and this controls a fan that's sitting up here. Now, this fan that's up here is because this motor gets rather hot. I do have to change the gear ratio. I originally started with this is a 90 watt motor. The first one I started with was a 90 watt 5K, which means it has a 10-to-1 reduction gear ratio, and it spun at 260 RPM on the output. I thought that would be it was a guess. I thought that would be a reasonable speed. Turns out it's far too fast. I'm going way too slow with the motor, and it would get too hot. It didn't have enough torque to do what I wanted it to. So I stepped up to a 10K, and the 10K now has enough torque to just barely do it, but I'm still only running at 40-50%. So I actually need to step to a 20K now, and the 20K will be I'll probably be running at more like 80%. And so the fan that's built into the motor will be spinning faster. I'm most likely not going to need this because it's also going to double the torque output. And so I might be able to remove this fan. That's why it's kind of jankily wired right now. It's still undetermined whether I'm removing it or not. So I'm just leaving it as is. It functions until I swap this motor out and have another engine to try it on. So I basically have to wait for me to do another engine build. I wasn't going to wait for another motor to come. I had to get that engine build done. So if I were to recommend anything, go to the 36 RPM. It went to 120. It'd be a 67 RPM because it was a 130 something. Yeah, 67 RPM is the next step down for the max RPM. So this one goes to like 120 or something. I'll go ahead and throw a link to both this motor and the even slower RPM, and I'll put the RPM and the cost of each motor. If I were to build another one, I'd probably go to the 120 watt version. Maybe I'll throw a link to that as well. But this is a 90 watt version. So if you want bigger, it will work fine. I do not want to go 120 watt version on this particular setup because of weight. You can see this giant counterweight I have on this end. If I did a 120 watt version and I built another one, I'd be doing it completely different. This motor would be over center here, and I'd have belt systems to actually operate everything instead of going way out on the end here. This is just too much weight on the end for the unit, and I'll explain how some of that functions here in a minute. But this thing does work really well considering that it was a first attempt at it. It did the job pretty good for me once I got used to it and got adjusted to it. There's a lot of quirks and tricks that you learn really fast when you're trying to hone. And as an example of one of those, here's a hone stone for the hone. This hone is 5 inches long. Most engines don't have a 5-inch stroke in them. Most engines have between a 2 and a 3.6 or maybe a 4-inch stroke if you're building a performance engine, but they don't really have that big of a stroke. So why is that an issue? Well, that means the cylinder wall is only 5-6 inches tall, and you can't go up and down very much because if you go down too far, you're going to hit something, and if you come out of the hole too far, you're going to create a taper on the cylinder because you're going to be hitting too much stone on the top of the cylinder. So you can only go up and down so far, and that causes more issues too because then if you're not crossing the stone a full path, it wears out the stone where the cylinder is contacting it the most, and then it'll just continue to create more taper or whatever in the cylinder, and you'll never get the cylinder round and true. So one thing I'm going to have to do because of how long these stones are on the next one I do, and I'm going to play with this, I did it differently on this one. I'll explain that too, but one thing I'm going to have to do is cut the bottom section of the stone off, a small amount, maybe a 1/2 inch or something. And I don't want to go too far because I might hit something in the block. I'm going to have to determine it on the block. If it's an LS block, I know how much I can go. I can literally go a 1/2 inch and I'll be perfectly fine. If it's a small block Chevy, I'm not sure. Big block Chevy, I'm not sure. I do have those blocks here, and I do have to do them eventually, but I'm not going to do them anytime soon. I'm not in a hurry. But the top of the stone, I'm going to remove a very large chunk, 1.5 inches, maybe 2. I really want to get this down in size. That way I can do a full sweep on the cylinder where the stone cuts across its own path several times to make sure the stone stays true, which will in turn make sure that the cylinder ends up true when it's done without less effing around. I had to do so much effing around with something like this. It's for one of those multi-tools, and it's for grinding down tile. You know, if you're in your house and you have to file down a little part of the tile so you can fit it somewhere, that's what this is for. And I was using this to cut the stone, and say the bottom of the cylinder needed to be cut more, I would take and wear out the top of the stone a little bit, come across, give it clean up, and then the bottom of the stone would cut the bottom of the cylinder because the top would not be contacting. And I was playing a game like that, so it was real finicky and fussy to do and kind of a pain in the ass, to be honest with you. That's why next time I'm going to be cutting the stone. I didn't do it this round because I wasn't sure if it was a good idea, but when I was looking up Sonnen hones, I found out that Sonnen actually makes a stone that is literally, it's got the full length mounting bracket, but a very small stone on it. And the Sonnen hone actually has, it's got the same type of thing, but where this thing is, you can see where the stone goes to, where they put it, and they brought it so it's just slightly over to the center a little bit more, so it sticks this direction a little more than it comes this direction. That way it's getting pressure from the middle, and that's how they make it so it actually cuts even. So I'm going to do the same exact concept with this stone. I'm just going to have to take my diamond wheel and cut a chunk of it off, and that'll work fine. Now, how do I get it to do this automatic up and down oscillation? There's a couple ways you can do it. I chose to go with an AC compressor. An AC compressor has what's called a wave plate in it. It's basically a plate that sits in there and goes like this. Okay? So this plate, it has multiple pistons hooked up to it, and those are what compress the gases in your AC compressor. So all I did was take one of the shafts that holds the piston. It's got a ball and socket joint in the wave plate on this particular compressor. Some compressors are different. Some of them use pins, and some of them use like a weird shaft with there's a piston on each side. It's very, very unique. This one had a ball and socket unit, which is perfect for what I needed, and it only had one set of pistons. And this particular air compressor is from a 2006 GTO. So if you want to do the same exact thing, there you have it. It's a GM air compressor, mid-2000s, right? They're probably all going to be pretty much the same. But I took the ball and socket. It's a steel shaft going into an aluminum squished ball and socket unit, and then it's got the same exact thing on the other end where it hooks to the piston. And I just took a cutoff wheel and cut the shaft off, and then I took and welded a piece of thick tubing that's actually, do I have it sitting over here? Got it right here. This is some heavy wall tubing that's actually intended for hardline of plumbing hydraulic systems in my skid loader. So I took this tubing and I was able to thread it to a 3/8 thread, and then I have a ball and socket joint up here. So I'm able to adjust right here. This is a set adjustment. Once it's set, I can forget about it. This is the adjustment I have to change to adjust the height of this guy here. This system has to change, though. I have to change this so it's a better functioning setup. What I'm going to do later on is I'm going to take and get rid of this stupid elbow here. It's going to come straight across with a pivot point coming out of the top of this. Then at this end, I'm going to have some sort of slide adjustable thing, because right now I have 3 holes in here, and wherever I set it in here and then these holes here, that's what adjusts how much stroke the unit actually has. So what I'll be doing is I'll set it up so it's got a slide deal up here, and then instead of hooking it up here, I'm going to lop this guy off of here, and I'm going to actually run it. Well, no, I won't, because I use it for this. I'm going to lop this part of it off anyway. I'm going to run a long shaft that goes all the way down to way down here with a pivot joint down here. I'll never have to move the bottom. all I have to do is slide the top to change how much stroke that it has. So I'll loosen a bolt, slide it, tighten the bolt. Done. It'll be that simple. That way I can adjust the stroke perfectly for each individual cylinder rapidly without any difficulty. If I need to concentrate the hone in a certain spot in the cylinder, I can simply adjust it, set it, forget it. And then of course, right here where this is, that is the adjustment for how high it actually sits up and down. I can actually adjust the height while the machine is running. This adjusts the height when you have the machine shut off. So if I'm watching, I can look underneath the engine block there. I can see how low the thing is coming, if it's contacting anything or not. And if I feel like it needs to be adjusted a little lower or a little higher, I just adjust this nut. That adjustment will pretty much be gone when I do that. I might come up with some kind of like this. These things, they have, one's a left-hand thread, one's a right-hand thread. So if you turn it one way, it adjusts it tighter and it adjusts it looser, right? I might do something similar in the middle of this, so I can just grab it by hand and twist it and adjust it. And then that'll be nice and perfect. It'll solve everything as far as this thing goes. It'll make it much better. I do have a spring here. I found it's not very good to have the spring. You can see the spring is pretty much compressed right now. I don't like having the spring in action, but I do have the spring a little loose. It's just so it allows a little bit of pivot. If you watch, you can see this thing kind of goes like this as it's moving, right? So I need a little bit of pivot room there. Once I do the actual long shaft deal and a ball socket on each end, I won't have to worry about the pivot. It won't be a big deal at all. So that's where I'm going to go with that. That'll solve that issue. So no big deal there. What else? I have, this is actually from the same parts washer. So ideally you want to buy yourself a parts washer because that tank, this hose that comes with it, everything is perfect for it. The pump, I really don't think the pump that comes with it will pump the fluid because it's meant for a thin fluid. I don't think it's going to pump oil. I did try using a fuel pump for my pump at first because I had a high performance vane pump. It could not pump the oil. So fuel pump doesn't work. I don't think the parts washer pump is going to work. You're going to have to come up with some kind of pump for the oil. But this piece from the parts washer is perfect because you just aim it just right, so it kind of comes across the cylinder wall and hits your stone every time the stone comes past it. It does a really good job of keeping the stone lubed and nice and wet so it doesn't get built up with debris, as long as you're spinning slow enough. If you turn this thing up and spin it too fast, it will plug up the stone, and then next thing you know, you're not cutting very well. So I found slower is better. It cuts more. It leaves a better surface. It just works so much better, right? So there's that. This guy here, how am I driving this? And is there any other option? If you don't like the AC compressor idea, you don't have one laying around, whatever the case, you could just drive a simple plate, right? And then do like a connecting rod and crankshaft type deal where you have one pin on the plate. Actually, you don't even have to have a plate. You could literally have just an arm sticking out with a bolt that swings around and creates a action in which it's going back and forth. But you're going to have to hook it to a lever to make the lever go back and forth to make it pivot like this, so you can hook it to something else to pivot down. It's going to be a little more complicated and a little more tricky to do. That's why I chose this. This was really easy for me to do. These guys here, I'll go ahead and link a couple of these. Don't use the ones that I link. It's just to give you an idea of what they are so you can try and find the correct ones. I used ones with smaller hole sizes because I have a lathe. So I went with small hole sizes. That way I could just lathe the hole bigger. Make a nice big hole to actually fit what I wanted to fit. This collar, I made it fit inside of this particular pulley cog. And then the pulley cog is tightened against the collar on one area. I believe, let's see here. I made this U-joint thing actually go inside the pulley cog, and then there's some Allen screws, see one right here, on the pulley cog that are tightened against this. I also made it a press fit, so I machined it a little bit smaller, the hole size, than the actual outside diameter of this. I pressed them together and then put the pin in, and then I had to machine a small keyway so that when the motor was actually... Oh, and I had to machine that too. Okay, so I machined this to fit the motor, and I made sure it was a nice tight fit, and I machined the aluminum here so it was a tight fit against this, and then I put it all together, and there is actually a keyway in there, and I believe I set the keyway, one of them, there, that one goes in deep. I think I set the keyway, or not the keyway, the Allen head, so that it actually goes in so far that it locks into the motor itself. So this guy is not coming loose, and of course I oil the pins here before I use the machine, and then this guy is filled with oil. If you were to look down here, actually I could probably just show you. Yep, there you go. See the oil? So there's a bunch of oil sitting in there to keep the swash plate and everything else lubed. Oh, I almost forgot something. I did have to modify this in order to make it function correctly. On that swash plate, there is a spring-loaded section. If you don't modify this, when it tries, I think when it tries pushing up or is when it tries pulling down, one of the two, when it tries applying pressure one direction, it'll actually compress a spring. You have to take, I used a piece of copper pipe. I found a copper piping coupler that slid over the shaft area, and I cut it at a certain length so it would not allow it to compress anymore. That way that swash plate can't compress, and it's forced to do the up and down function no matter how much pressure is against it. So like right now it's at the top. If I push on this, the only thing it'll do is turn this and make it go, right? So if I have it up and I hold this so it can't turn and I push on it, it's not going anywhere except for compressing the spring. So that's the only thing that moves. You don't want this to compress because then you're not going to get a nice crosshatch pattern on the cylinder. Also, these two cogs do not get a 30 and a 30. You're not going to be happy with that. You have to get a 30 and a 28 or a 50 and a 51 or something like that. It has to be off a little bit because if you get the same size, your hones, when they're doing the 45 degree, every time it comes around, it's going to cut the same exact path. And if you cut the same exact path, next thing you know, your cylinder is going to go from a round cylinder going perpendicular to a not round cylinder that's tilted. Because it's always going to cut the same spot. It's never going to cut a different area. So you want to have a different timing so that it slowly changes where the stone cuts every time it comes around. Counterweight. I had to build a giant counterweight on this, and I tried playing with springs, tried getting it to work with just springs, and no matter what I did with springs, it always just, the machine did not seem right. I ended up doing a counterweight, which is really heavy on this end because of how little leverage it has on that end versus how much leverage the weight on this end is. That's where I would do things much differently, and I would have this motor here, and I would just use a belt system in order to drive everything with a separate lighter weight end on this end. And then this compressor would be on the back to counter everything, because that counterweight actually causes a problem. If you try and go at a faster speed at all for any reason, the counterweight has too much momentum between the two sets. You know, you start rotating this way, and then you got to try and switch directions. It actually kind of fights and makes this thing a little bit slow on the top and the bottom. So your crosshatch pattern coming up and down, you have, instead of it just going up, down, it's got a swoop, right? And that's also part to do with how the swash plate works. You can see it hesitates at the bottom, it's still turning, now it's going up, right? And then when you get to the top, I'm turning, now it's going down. So you end up with a swoosh pattern, but it gets even more amplified because of the extra weight. So if you can engineer it to be towards the middle, you'll have an even better hone machine than I do, and I might do that sometime in the future. This project was a fun project to build. It works phenomenal. The first few cylinders I did took me a really long time to do, but when I got down to the last set of cylinders, the last 4, I started to really figure the machine out, and on the last 2, I had it down to a 2 to 2.5 hour process per hole to take about 4 thousandths of material out, 3.5 to 4 thousandths of material out. And I ended up with a perfect finish on the cylinder when I was done. So this thing does a phenomenal job, and the best part about it is if I cut these stones shorter, I'm going to have even less babysitting, but the lack of babysitting needed. So you initially have to babysit it right at first when you first start cutting that cylinder, because you got to get the stone to cut perfectly. You got to make sure you're not cutting too much in one area, not the other. You're only cutting the spots that you want. Once you're cutting the spot you want, you tighten this thing down, you walk away, you let the machine work while you go do other work. That is the best part about this machine. The second best thing about this machine is you're not sitting there going like this, and by the time you're done with an engine block, you're going like this. All right. Overall, very happy with it. Oh, this is my method of holding the block. I almost forgot. Oh, and to talk about the springs. Forgot a couple things. This actually is my mechanism for holding the block. So you set your block on the bar here, and while the block's on the bar, you got to make sure the cylinders are parallel with the hone. You don't want the hone going in there like this, right? Obviously. So you got to set it so it's as straight as you can kind of eyeball it. You don't have to be perfect because it's got a lot of movement here, but you want to be as straight as you can. Just, eyeball it this way, then eyeball it this way, and once you're good, you can forget about it. So you set your block on here, you get it centered this direction to whatever hole you're working on. You just slide it over. You do want to put the bearings, the junk bearings, in the block if you can, because that way you don't wreck the mains. This is steel, so I just threw the stock bearings in the top, set it in there, and then I put the main caps on, 2 of them. 2 bearings, 2 main caps, just in case the thing were to rotate over so it doesn't crash into my tank down below here, right? Just in case I accidentally let go of it or something, it wouldn't be the end of the world. But you put that on there, set it on there with a cherry picker, throw a couple bolts in there. You don't even have to tighten them down, just something to keep it from flipping. And then this guy here, you put a stud in the head, and you rotate it, and you set this on a stud, and the weight of the engine will hold it against that. If you're doing the front of the engine's up here, you'd be doing the left bank. Then the other bank is going to be facing over here. You can put this in one of the head bolts. If you're doing the right bank, you flip it this way, and now you're going this direction, but you have nothing to hang on to. You can take this guy and go across it like this into the head bolt area again and throw a bolt in there, and then you just adjust these clasps accordingly. Ideally, I should probably just use one of these things and a chain, but I'm actually out of chain right now. I don't know why I ran out of chain. I just did. I keep using it for all kinds of projects. So I got to get some more chain. And I was just at Menards today. The things you realize on video. Whatever. I should have got chain today. But I want to get some chain, and then I should just have one of these. Because you can use different chain holes to get it close, and then use this to fine-tune the adjustment. So use chain. This is kind of a weird way to do it. I had a bunch of these sitting around. So that's how I hold that in place. The spring system here, I do have a weird spring system that I should explain, that it will be helpful for you. So you see I got the big counterweight here, and this weight over here, and then I got a spring here, and a spring sitting over this direction. This spring just holds the chain so it doesn't flop, okay? So when this thing gets to the top on the hone, or the bottom on the weight, see how loose this chain is? If I don't have this spring in place, this chain flops every time it comes up and down, and you can hear it slapping. But by putting this other spring in here, it just kind of keeps a little bit of tension on the chain just so it doesn't do that. This is actually a chain from a LS build engine. It's a leftover chain. I just welded it inside the tube. And then I can adjust the spring height. That was so that I had plenty of adjustment to try and figure this out. And then this spring is from some kid's trampoline. It was in like a dump site for the city dump. There was a trampoline dropped off in there with a bunch of exploded springs laying everywhere. I just grabbed a handful of springs, threw it in my truck because I was like, hey, I'll find a use for those springs. And sure enough, I found a use for them. This spring right now at the top is very loose, right? There's almost no tension. That's because I don't want the motor to work against the spring. So what happens here is as this thing turns, you can see as it's going down, the weight and momentum is going to pull on that spring. The weight and momentum will allow the motor not to have to work against the spring, but the spring will help the motor pull that weight and momentum and switch it back in the other direction to go back up. So it makes sure this keeps easy, and the way you can kind of tell is just by doing it by hand. If it's nice and easy to turn by hand, you did something right. Like right now, it's so easy for me to do this. I can just kind of operate it. You want as little energy from the motor going into the up and down motion, and as much energy as possible going into the hone itself. That way you don't waste so much energy in just transitioning. It really doesn't take much energy to do. So what's a machine like this actually cost? For me, $115. What else did I buy? Did I really buy much of anything? Oh, I did buy this, but I bought this a long time ago. I think I paid $205 for this. I'll throw a link for this in the description too. I'm going to do a sun and hone on here at some point. I might just build a whole nother machine for the sun and hone. The sun and hone system is a little bit better hone system. That's why I want to go to it. I want to go to one of the juniors, and then of course you can step up to a bigger stone for a bigger cylinder too. And then I'm going to make a bigger machine if I make another machine, because I'm hoping to keep this machine long enough that I'll get my add-on to my shop where I have another shop. Right now it's going in the shipping container. I needed a small machine that took up very little space, but I would like to build a big machine in the future. So my future machine is going to be a sun and hone with a 120 watt motor that's mounted up here. Cost about $215, 112, so that's $3 something. That's what I bought. That's it. Oh, stones, of course. You have to buy stones. But stones, let me think. What would you have in the stones? It's about $15 a set. So I got 1, 2, 3, 4, 5 grits there. 5 at 15. So 4 at 15 would be 60. So it's $75, right? So we're at 400-ish, depending on taxes and increases and stuff. So we're at $400-ish of investment that I personally put into it. What would somebody building this from scratch have to do if they don't have all these supplies? You could probably pick up a parts washer for $120 at Harbor Freight, maybe a little more, I don't know. I know they used to be about $110. Harbor Freight prices haven't changed much, I don't think. So you might still be able to get one for around $120. All you need is the cabinet, really. You don't even need the pump system. So hopefully you can find one at a deal. Maybe you can find one at a yard sale or a garage sale or somebody selling one. Either way, $120. So now we're at $500. We'll say $500, $550 because taxes and inflation and things. So $550. You're going to need some hose. Steel. Steel is expensive. This 2x3 square tubing is probably, I don't know, $80 to $100. We'll say $100 just to make the math easy. So we'll say $650, right, in steel. Well, with steel, $650. Air compressor you could pick up at the junkyard for relatively cheap if you wanted to. Probably $20, $30 if you pull it. So $670-ish. This is a 4-inch axle from a tractor. I don't know where the hell you would get that. It's a 4-inch solid bar. It doesn't have to be round bar. You could find just a big chunk of iron. But iron by weight does get pretty pricey. I don't know what that's going to cost. You're going to have to try and figure that out yourself, I guess. We could just say $50. I don't know. I have no idea. Let's just bring it to $700 to make it easy. Let's say it's $30. I have no idea. So $700-ish. You're going to need some switches, some wires, 720. Because we'll just add some random things. You're going to have to come up with a pump. You might be able to do that weird Amazon pump. You could try it if you want. I think it was only $20 or something. But if you can build something like this, it'd be much better off. So let's say you're into it. We'll go a little high. We'll go $850. Let's say you're into it for $850 to be able to hone cylinders automatically like this. You would not believe how much time and energy that will save you versus this and a drill. And seriously, a drill is $150, $200 for a plug-in drill. That's a decent drill. It's going to hold up to something like this. This thing is pretty stressful on a drill. So $400 versus $700, and it does it automatically. You don't have to sit there and manually do all the work and stand up and break your back and all the rest. Well worth the money, especially if you consider what a sun and hone cost for the actual manual one that you have to do this to. And I think it has a foot pedal. I don't recall. But either way, that sun and hone is like $5,000 used, which is absolutely insane. So, oil. We're going to go to $1,000. The oil was $150 for a single 5-gallon jug of it. I should have 2 jugs. I put one in here just because I was trying to keep it on a budget. So that's $300. So easily $1,000 now, right? So we're easily at $1,000, but we have a really nice hone machine that does a phenomenal job, and I am more than excited to use this thing again in the future. The first round was tough. admittedly, because I was trying to learn the thing. But now that I think I have it figured out, and I'm going to swap out this motor, I'll be tickled pink next time I use it, because it's going to work so much better just because I know how to use the damn thing. So, I'll leave it there. Hopefully you guys like this video. Leave a comment below. What do you think? Do you guys like this hone system? Like, share, subscribe, and as always, I hope to see you on the next video. Sorry I've been out for a while. I have not been posting. I've been way too damn busy. It's about time I get a video out. So here you are. Here's a video. I have a F-150 turbo on a Coyote that I did. And that video, hopefully I'll get edited. I also have coming this winter a 2022, well, that was a 2022 F-150, by the way. I have a 2022 BMW M8 that's supposed to be coming this winter. He's supposed to come this weekend so we can order parts. But that's supposed to come this winter for me to do some upgrades to. That's a really expensive car, so that's one I'm going to have to make the shop spotless and really keep the kids out of the shop. I do have kids. I'm going to have to keep the kids out of the shop so they don't dare rub their filthy, scratch-full hands all over the side of it. But I'll do what I need to make sure I take care of that customer and get that job done. So I look forward to that. Hopefully I'll be making a video on that as well. I definitely did a video on the F-150. I just have not edited it all. That's the big problem with videos and why I haven't been posting. So I will see you on the next one. Thanks for watching again. And as always, I look forward to future videos, and check me out on Rumble.